Welcome to watch AEC CutFill program training video. AEC CutFill is fully automated highway cross-sections design with drafting tools on AutoCAD that can generate about 1,000 cross-sections a day per system against 25 manually. The solution is divided into 3 parts. Part 1 being design as per country-specific highway standards. Part 2 handles most drafting tools on AutoCAD to suit any approved title block to present cross-section data. Part 3 generates data input files that are used in designing cross-sections in Part 1. Type CutFill at command prompt to load AEC CutFill menu bar. AEC CutFill menu bar contains about 40 customized command tools to carry out drafting. Click Generate Cross-Sections to open AEC CutFill Designer. Alternatively, open the Designer from shortcut on your desktop. Set project file name and folder path. Check for 3 input data files such as GDL, FRL, OGL be available on your system. Cross-profile of your project at each station comes from top definition lines file that should contain station, side, offset and slope. Longitudinal profile comes from FRL file that should contain station, center offset usually at 0 level, X and Y coordinates. OGL data must contain 3 fields: station, offset and level. Repeat station for several offsets. Minus for left offset from center. Import 3 data files one after the other. Verify top definition lines from graph window below. Center line coordinates from FRL file are separated to this tab. To add berms at high embankments and deep cutting, follow pictorial instructions in next few slides. To add tow drains, follow pictorial instructions in next few slides. Apply DDL and drain templates so defined in previous steps for every station. To configure pavement layers in your project crust, follow pictorial instructions in next few slides. Configure every pavement layer above embankment top. Define start and end conditions, offsets from above layer, slope towards next layer. For single carriageway, define start offset equals 0 and start slope equals 99,999. This has a meaning of maximum slope near to infinity, or near to true vertical. Some projects do not allow slope portions of pavement layers as payable quantity. Check this box to exclude in computations. National highway design standards many times are complicated, taking into consideration of both slope fixed and offset fixed scenarios. The program solves these definitions through complex algorithms. Define soil type if not found and select. Choose tab fill slopes. Enter range of height and enter slope %. Check if the range has condition of slope fixed. Follow similar instructions to cut slope configuration. When cutting portions contain shoulder drain, it must be defined in offset and slope format. Follow pictorial instructions in next few slides to configure color settings of DXF output files. It is time to use the run command to generate cross-sections and write output files to the folder we created in the first step. Program runs with complex algorithms to compute quantities and write drawing files taking into consideration of all predefined constraints, definitions, offsets and levels. Drop definition set to crust top checkbox, if checked includes crust layers, else excludes. Vertical thickness checkbox if checked, crust layers thicknesses are calculated parallel to y-axis, else the thicknesses are considered perpendicular to crust top surface. It is assumed that the section of project length under consideration has only one soil type in cutting and one soil type in filling. Check if station values are given in kilometers. For shoulder breakpoint rounding offsets, set value for first offset towards slope and the second offset towards shoulder. Check to set toe drains to include in design. Two output files are written to the project folder such as area report, in CSV format and drawings, in DXF format. Part 2 of this video discusses drafting tools on AutoCAD platform to automate manual work. Open output DXF file so generated in Part 1 with AutoCAD. Version of AutoCAD needs to be compatible with installed AEC CutFill program. Cross-sections are drawn station-wise on layers. Use laywalk command to view each layer that contains one cross-section. Laywalk command enables to view how each cross-section is designed as per contract project definitions. Delete improper sections if found. Regenerate if input data errors are found. Applying approved title block to each cross-section layer. Open a drawing in which the approved title block is existing as block reference. Select and copy the title block. Paste the title block anywhere in the project drawing on a blank area. Use the command, apply title block. Inform the program of the layer on which graph grid is drawn. Pick grid center point when prompted. Enter graph x-axis length. Enter graph spacing. Enter number of grid lines along x-axis. Choose X style for datum. Title block is applied for all cross-sections in all layers. Since the title block is in layers, we must push them to 0 layer to appear in every layer as block reference. Select the title block when prompted. It's done. Laywalk to see the title block applied to every cross-section layer. Datum is adjusted according to grid spacing. Program creates grid center point for every cross-section. User may not remove such system-defined points. Drafting tools to place cross-section related data at desired coordinates on the applied title block. Configure settings to automate faster drafting. TDL dimension settings are configured in this tab data grid. Enter lane name, start and end nodes or vertex numbers of TDL. Enter y-ordinate value or double-click the cell to pick from the drawing interface. This is the distance above grid center point, GCP, or TDL center point, GCP. If is relative is checked, then the y-ordinate is considered from GCP, else from GCP. Set text height, dim style, rotation angle and text style and click OK to save. TDL requires offsets and levels data to be shown in drawings for execution. Choose option, both sides are left or right. Enter leader line length and angle. Set text height, rotation angle and style of the leader text. Enter comma separated nodes or vertices of a TDL to set leaders. TDL requires slope arrows data to be shown in drawings for execution. Choose option, both sides are left or right. Enter arrow line length, text height and style. Enter comma-separated nodes or vertices of the TDL to set leaders. Choose format either in slope % or horizontal to vertical ratio. TDL requires plan coordinates to be shown in drawings. Choose option, both sides are left or right. Enter leader line length and angle. At node 1 the angle is always 90 degree. Enter leader text height, rotation angle and text style. Enter comma-separated nodes or vertices of the TDL to place coordinates labels. Optionally you may enter X offset from each node point to calculate and set coordinate labels at such location. Cross-section requires OGL data to be shown in drawings. Enter Y ordinate for placement of offset text or click Pick button to fetch from drawing interface. This is the distance below grid center point, GCP, and level text placement. Repeat same step for level text. Choose text style and height. Cross-section requires every pavement's layer levels to be shown in drawings. Enter 0 or a value. If the entry equals 0 then levels are written at every node, else the entry has a value then levels are written at value intervals. Choose text style and height. Enter Y ordinate for placement of level text or click Pick button to fetch from drawing interface. This is the distance below grid center point, GCP, and level text placement. Every cross-section requires pavement layers quantities to be shown in drawings for planning and invoicing. All quantity-related data for each cross-section are managed in this feature. Pavement layers are automatically appeared based on pavement design created in Part 1. Choose text height, style and rotation. Enter X and Y ordinates in data cell or double-click to fetch from drawing interface. If required, enter added value to add to the data value to write in labels. Cross-section requires general entries like date of submission, drawn by, checked by, scale and the list can go on. Enter in text string but every cross-section should bear such labels. Set text height, style, rotation. Enter X and Y ordinates in data cell or double-click to fetch from drawing interface. Let us see how auto-drafting feature can automate your work based on predefined settings in the previous steps. Auto-drafting command writes data to title block placeholders and decorate your cross-sections with several dimensional and data features. Placements, coordinates, styles, heights are read from predefined settings. A kilometer-long project with 100 cross-sections that contain approximately 20,000 items of data are written in 10 minutes. After this command these 100 cross-sections can be ready for printing in submittals. Settings may have to be changed for each title block changes to work the way you desire. Data populated after auto-drafting. Image when all layers are on. Data populated after auto-drafting. Layout to see each cross-section. Few hundred data features are added to each cross-section by the auto-drafting command. And if you need to add more features, use feature-wise commands that operate on all cross-sections at a time. Closure look at a cross-section with data and features written after auto-drafting. Feature-wise drafting writes data labels to title block placeholders and decorate your cross-sections based on predefined settings. All cross-sections are drafted at a time. One such example is shown in the next few slides. Let us add a feature slope data label to side slopes in HS2V format, as vertex 10 on TDL, using slope arrows feature command. System opens the settings form with arrows tab to make any changes to the dimensions, format and options of the feature. Side slope arrows in HS2V format written to all cross-sections in all layers. For convenience, only one layer is on. Use Layout command to view side slope arrows and H's to V-format and other cross-sections in different layers. Let us try another extra command to insert blocks at a distance of 0.6 meter from vertex 1 on TTL. System interacts with the user to seek data block and options to insert in all layered cross-sections at a time. Blocks inserted in all cross-sections. Use Layout to see the effect. Program enables to set plot styles to every line that has been generated during design. Choose line type scale, line weight and color as shown in the following slides. Apply the plot styles so defined in previous step using the Apply to All command. It's time now to generate prints out in PDF or other soft formats. Set several self-explanatory options to generate prints out for a range of cross-sections to your project folder. Note that we select the same title block the project length was configured, which can fit to the paper size we chose to generate prints out. Cross-section-wise prints out in PDF format are saved to the project folder. Your project cross-sections can be transferred to plan alignment if you had supplied coordinates in the FRL file. System creates a new AutoCAD file and saves it a file path indicated when prompted. Open the drawing file Plot to Plan to view your cross-sections on 3D plan. Use AutoCAD Orbit command to see effect and accuracy of your data supplied and data generated as per project configurations. What you see is what you get. No more words to prove the solution.